Hey, let's talk about lechateliers principle. Okay, lechateliers principle states that when a stress is applied to a reaction at equilibrium, that reaction is going to have to do something. Okay, that's what lechateliers principle basically says. Okay, the reaction is going to shift in one direction or the other to relieve stress. Okay, so here are some things that we can do. So let's say that this is my reaction. Okay, I have reactants that turn into products. Okay, if I add a reactant, okay, so I increase my reactant side. Notice in my reaction, I'm making my reactants go up, okay? If that's going to happen, then I have to shift to make more products to make it go back to equilibrium, okay? If I add products, okay, I have to shift my reaction to make my reactants go back up. So I'm going to add more reactants, okay? So if you use a pencil, okay, if you label a pencil with reactants and products, then you can use this little trick on your own, okay? And so you can use a pencil and say, oh yeah, if I increase my reactants and I've got to increase, whatever you need to do, okay? Let's look at a couple more. If I remove reactants, okay, so my reactants go down, okay, what do I need to do? I need to make more reactants, okay? If I remove products, okay? Now, this is one that actually kind of happens in industry, okay? Let's say you've got a reaction taking place and you've made some products, okay? And because you may be saying to yourself, what does this even mean? Remove this, remove that, okay? What does this even mean? Well, if you are in industry, okay, and you have done a reaction and you've made a bunch of products, okay, then so now you've made a bunch of products and now you're going to take that product away, okay, and so now your products are going to go down, okay. In order to get that back to equilibrium, you have to make more products, okay. If you remove reactants, okay, you have to make more reactants, okay, pretty easy. Now, two of them that don't deal with the little shifty do thing. It says if you increase the pressure by decreasing the volume, you're going to shift to the side with the least number of moles of gas. Okay, how do you find that information? Look at the coefficients. Okay, if you decrease the pressure by increasing the volume, then you're going to shift to the side with the most moles of gas. Okay, what if you increase the temperature? Okay, if it's an endothermic reaction, you know that heat is a reactant. So basically, what you're doing is you're adding a reactant if you heat up the temperature in an endothermic reaction. So therefore, you're going to shift to make more products. Okay. In an exothermic reaction, if you increase the temperature, you're basically adding more products because heat's a product, and then you have to shift to make more reactants. Okay. In an endothermic reaction, if you decrease the temperature in an endothermic reaction, basically what you're doing is you're removing reactants. Okay, so your reactants go down, so therefore you have to make more reactants. Okay, and in an exothermic reaction, if you decrease the temperature, then basically you're removing products, so therefore you need to shift your reaction to make more products. Okay, what does all this mean? Let's take a look at a reaction here. This says that we're dealing with the Haber process, and it gives us the reaction for the Haber process, okay? And so we know that this is going to be N2 plus 3H2 yields 2NH3. And it also tells us that the delta H is 96 kilojoules, making this exothermic. So we're going to add 96 kilojoules to the product side, okay? Now, what happens if we add hydrogen? Well, hydrogen's a reactant. So if we increase our reactants, then this is going to shift to, we'll just say it's going to shift to the product side, okay? We're going to shift to make more products, okay? So if I have increased my reactants, then that means that the change in reactants to establish equilibrium, my reactants are going to go down and my products are going to come back up. Okay? What if I remove ammonia? Ammonia is a product, so therefore my products go down. So I am going to shift to make more products. Okay? In order to establish equilibrium, I have to increase my products and decrease my reactants. Okay? What if I heat the reaction vessel, okay? Well, if I heat it up, okay, I know that heat is a product, so I'm increasing the heat, so therefore I'm basically increasing the products. So this is going to shift to make more reactants, okay? So I'm shifting to the reactants side. So therefore, I need to increase my reactants and decrease my products, okay? If I increase the volume of the reaction vessel, okay, let's go back and look and see what that means, okay? If I increase the volume, I'm essentially going to decrease the pressure. So therefore, I'm going to shift to the side that has the most moles of gas, okay? Well, all of these are gases, okay? This is a gas, this is a gas, and this is a gas. So if I'm going to shift to the side that has the most moles of gas, I've got 1 and 3. This has 4 moles of gas, and this has 2 moles of gas. So therefore, I'm going to shift to the side that has the most moles, which is my reactants side. Therefore, I'm going to increase my reactants, and I'm going to decrease my products. Okay, so that gives you an idea of what this whole situation's doing. Okay, that is lechateliers principle. That's lechateliers principle in a nutshell. Okay, we will practice on this in class, and that is our last concept. So have a great day.